Hi everyone, this video we're going to look at the scalar product of two vectors. This is the third unit on vectors here, and we're going to deal with this thing called the scalar product. So it seems strange an idea that we want to multiply vectors together. That's a bit weird, but there's two ways of doing it. One we'll learn next year. This one is called the scalar product. So let's look at how we do it. Suppose we've got two vectors A and B, and the angle between them is theta. Now notice that these vectors are both going away from this point here where they intersect, and that's kind of important for getting this right. Both the vectors are going away, or both the vectors would be coming in towards the angle. So you've got to have either one of those. Okay, so that's important. Both point towards or both away from the point of intersection. Okay, so that angle there is not theta. If we do it the other way around, if one's going in this case B is going into the angle and A is going away, then this is the angle between them. Okay, so that theta in this case is an obtuse angle. So that's just a good thing to get in mind when we first start doing these. The scalar product we write with a little dot between the two vectors, A dot B, and it's defined by A times B times cos of theta, where A and B here are the lengths of the vectors A and B. That's what they are. So that dot, you can never miss that out. That is a new way of kind of multiplying vectors, and we're going to see what this thing is and what it does. Let me quickly look at the geometric interpretation here. So let's have a look here at this unit circle here. We've got two vectors. Now the dot product here is the length of this blue vector here. If we take this vector here, and I'll move it around, sorry, I'll move this one around, and you can see that the projection, or the length of this vector, we call it the projection onto the other vector, that length is the dot product. So for these two unit vectors there, that length can never be more than 1. Okay, so if I move this one around, you can see what happens. It's just the projection of that vector on top of the other vector. Okay, that's the interpretation of the dot product. So if we look at this interpretation, you can see that as we go around, we get to this point here where the vectors are perpendicular to each other. You can see the projection, the length is 0. If the vectors get more than 90 degrees, so if it's now an obtuse angle, you can see that the length here is now negative. Okay, that red line there is negative. If we get to 180 degrees, you can see the length is 1, and we'll actually be negative 1. As we come around again, 90 degrees, the length is 0, and now the angle between them is acute angle again, and you can see the length of that blue line there. That is what the scalar product or the dot product is. I'll make these vectors bigger. You can see in this case, when I move this vector around and move this vector around, the dot product can get bigger than the two vectors. Okay, so remember, the dot product or the scalar product is just the length of that line. It is a number. It's not another vector. It's an actual number. Okay, so let's look at some examples here. So for this one here, we've got a vector length 8, length 10, the angle's 30 degrees. Then the dot product or the scalar product is 69. Now in this case here, do the same thing, and the dot product is 52. So notice that it uses the magnitudes of the vectors as well as the angle in between them. So we'll get different answers for different size vectors and the same angle. If we have the same size vectors and different angles, we'll also get different answers. Now I know straight away that one on the right there, the answer is going to be negative. Okay, so that one there is 52. If you type that one on your calculator, you'll get negative 52. Okay. So really, the purpose of the scalar product, it's the thing that we use it for all the time, is finding the angle between any two given vectors. Now you might say, well, it's pretty easy to find the angle between two lines in 2 dimensions, and it is. But if you get lines in 3 dimensions, that's tricky. So this is where this comes into its own when we start looking at 3-dimensional examples. So far we're just looking at 2-dimensional examples. As I've said, if the vectors are perpendicular to each other, we get in this formula here, cos of 90 degrees is equal to 0. So therefore, this whole thing, the dot product, is equal to 0. So that's another important thing. Okay, so let's just look at one example here. Pretty simple. Find the scalar products. On this one here, we'd have 4 times 6 times cos of 60. That would be the dot product for that one. This one here, because the vectors are perpendicular, the scalar product or dot product would be 0. Okay, so let's look at those. The first one, the answer is 12. Next one, the scalar product is 0. The next one, hopefully you can see the 120 degrees. Oh, because B is coming in here and A is going away, then the angle we're looking at is this angle here, which is 60 degrees. So the dot product in that case is 8. So remember that convention that both vectors need to be going away from the point or in towards the point for that angle in between them to be the one that you use. Find the value of A dot A for any non-zero vector A. So if we dot a vector with itself, we just get A squared, which is the length of A squared. If I was a unit vector, then I dot I is just going to be equal to 1. And I dot K, obviously they're going to be 90 degrees to each other, so that's going to be equal to 0. So there's some few introductory ideas around what the scalar product is.